Okay, this week, put our phones away. Joe. All right, so this week we're going to solve systems of equations. All right, stuff you've done like every year in math of your high school career. All right, so it's review stuff. All right, we're going to solve a system by substitution and elimination. Okay, so we'll go over those two ways today. All right, and then tomorrow I'll give you a little practice quiz to work on. Avery, come back. Yeah, we'll have a late start tomorrow, but we'll still we'll be able to get together though this week. Last week we didn't get to have class, Tuesday and Wednesday, but we'll still get together for a half hour tomorrow and Wednesday. You need to be here. And then Thursday's the quiz, because we don't have, school Friday, it's Good Friday. Griffin. Yeah. 2 hour delay. So gotta be here. It's only a 2 hour delay, not a 3 hour delay. All right, so you gotta be here at 9:30 tomorrow and Wednesday, right? Okay? So we'll get to see each other tomorrow and Wednesday. All right, so solving by substitution. You have to get one of the variables by itself. It's your choice. You can get X or Y by itself. Now I always look for one of the variables that has no number in front. Okay? So I would pick either this first Y or either one of these X's or Y's to get along, because there's no number in front. There's a number in front, and you can get that 3X by itself if you want, but you're going to end up dividing by 3 and get some fractions probably. So trying to avoid the fractions, get one of the variables by itself that doesn't have a number in front. Then you don't have to divide. So I'm just going to get this Y on the left by itself to start this problem. And you can write 1 minus 3X, or you can write negative 3X plus 1. But those aren't like terms, so I just have to write that out. Okay? Now I have to take that 3X or negative 3X plus 1, and I have to substitute it for Y in the other equation. That's the first substitution in the substitution method. Get one of the variables by itself and then substitute what you get for that variable into the other equation for that variable. So we got Y by itself, so I'm putting that negative 3X plus 1 in place of the Y on the other equation. So instead of Y, I write the negative 3X plus 1 for the Y, but then the rest of it you have to put in it. Minus X equals 9. So now I have that equation with one variable in it. So now I'm going to get X by itself. So what's the first thing I want to do? Combine like terms. So what's negative 3X and a negative 1X? Negative 4X. Okay. Now what am I going to do to get X alone? Subtract 1 first. So now we're half done. Why are we only half done? Yeah, you got to find what X and Y equals in these, right? We got two equations with an X and a Y in it. That's why it's called a system of equations, because we got two of them. And we got to find the X value that works for both and the Y value that works for both. Okay? So what I'm going to do now is take this negative 2, and I'm going to plug it in for X right there. Now you can do one of the original ones if you want, but I always go into the one, since I found X, I know I got Y equals over there on the other side. So that's where I'm going to put it. So I'm going to write Y equals negative 3 times negative 2 plus 1, which is 6 plus 1. So use usually we write our answers as an ordered pair. The x value is -2 and the y value is 7. And you can check. 3 times -2 is -6 plus 7 would be a +1, right? And then 7 for y minus a -2 is like +2. And 7 plus 2 is 9, right? So that those two numbers work in both equations. Thank you. You guys remember this, don't you? You guys have done this before. Simple, right? Any questions on that example? We good so far? Can we do one on our own? All right, go ahead and try this one on your own, please. Solve that system of equations by substitution, please. Okay.
Right. Oh, it's 11. Oh. I wrote everything down.
All right, you guys are doing a good job. Which of those 4 variables are we going to get by itself? That's the easiest. The negative y, right? We all understand why we want to get that first y by itself? Now, if you pick any of the others, it's okay, but you're going to get some fractions, that's all. Okay? So the first thing I'm going to do is subtract 2x. But it's negative y. So what do we got to do? Yeah, divide everything by negative 1. Let's get what positive y. Oops. Let's make that look better. And everything gets divided by negative 1, remember. So we get y equals positive 2x minus 2. So I take this and put it in the y in the other equation, remember. So I get 3x minus 2 times y, which again, y we just made as 2x minus 2. So we're going to distribute that negative 2 through there now. So we got 3x minus 4x plus 4, and that's negative x plus 4. Subtract 4. Negative x is 7, so we got to do that divide by negative 1 again to get what positive x is. So there's our x value. And then I'm going to go here to find my y value. So y equals 2 times negative 7, negative 14 minus 2 is negative 16, right? So our ordered pair, x is negative 7 and y is negative 16. Make sense? All right, let's do one more substitution and then we'll talk about elimination. You guys are doing a good job for a Monday morning.
No, I'm gonna get a text. I really looked at the file. I really think it is right now. And I'll say, do you want me to hang out with the or like, I'll have contact with myself. Or like, I'll be at my house or how fucking bad it is. It's so
It is hard.
He's nervous.
You can't do
I don't
it.
think he's nervous.
Okay,
I don't think he's nervous. Very good.
How'd you get back to conclusion? Well, you get x equals negative 3y plus 6, plug that in, and the y's cancel. Do you still get to use a variable?
Yeah,
There's no,
Thank
there is no y, there's no y. You can't plug it in to get the y. Yeah.
Yeah.
That's 12 equals negative 8. I would get that. It's okay. That's your y, right? I tried to.
His brother is so weird. What if you die? No, I think we conversation.
What'd you do here?
I didn't know if you could pass that.
Okay.
6 plus 6 y.
So we're gonna go, right?
Yeah.
So that's true or false? That's
False.
right. So if it's true, infinite number of solutions is false.
Okay.
What if he just like comes into the room? He does.
All right, what happens with this one?
No solution.
It doesn't work.
Yeah, it doesn't work, right? Okay, sometimes this will happen. So, again, I like to get the variable that has no number in front by itself. But it's not wrong if you get that 3y by itself. You just get a 1/3 somewhere, right? It'll still work out the same way, right? But I think it's easier to get that x by itself. So we get x equals negative 3y plus 6, and we take that and put it in for x. Any questions on that? Distribute the positive 2. We get negative 6y plus 12 plus 6y equals negative 18. What happens to these two 6y's? They cancel. So I get this statement. Is that a true or a false statement? That's a false statement, okay? So when you get a false statement, you just say there's no solution. There's no number that works that you can put in for x and y and it'll work in both. Right? That's what we're trying to figure out. What x value and y value works in both. Now, if this was 12 equals 12, that's a true statement, right? Then what do we say? There's an infinite number of solutions. We can pick any number for x, figure out what y is, and it's going to work. Or pick a number for y, figure out what x is, and it's going to work for both, if it came out to be a true statement. But this one didn't come out to be a true statement. Okay, so sometimes that'll happen in the system. There's no solution. There's no numbers that work for both equations. All right, let's go to elimination. Good job so far. Okay, so when I do substitution, I like to write them side by side. So I get one by itself, then I go to the other side. When I do elimination, I like to, that's the wrong one. When I do elimination, I like to line everything up. So I like to have my x's, then my y's, my equal sign, and then my constants. Okay, so sometimes they'll try to mess with you and put the y first, and then the x, when they write the problem. But when you write it, put the x, then the y, so everything lines up. Okay? Now, in this method, you want to eliminate one of the variables. Okay? So I look first at the coefficients. And if they have the same number in front, that's the one I'm going to eliminate. So in this problem, which one am I going to eliminate? The x's. They have the same number in front, right? They both have 2's in front. Now I look at the signs then. Once I figure out which variable I'm going to eliminate, I'm going to look at their signs. And these signs are opposite. I got a positive 2 up here and a negative 2 there. When the signs are opposite, you add the two equations together. When the signs are the same, you subtract the two equations. Okay? So in this situation, these two are opposite signs, positive 2, negative 2. I'm going to add the two equations together because they both have a 2 in front of the x's. And what is a positive 2 plus a negative 2x? 0x, right? Cancel. They are eliminated. That's why they call it elimination. What's a negative 5 plus 8y? 3y. What's a negative 5 plus a negative 58? Negative 63, right? And then I divide by 3 to get y by itself. And that's negative 21, right? Am I finished? No, I got to figure out the x. What do I do to figure out the x? Plug into y into either one. It doesn't matter. I'll just do the top one. I'll plug in up here. So I got 2x minus 5 times negative 21 for y equals negative 5, which is 2x plus 105 when I multiply negative 5 and negative 21. And then I'll solve for x.
Where did you get 105?
5 times 21. I multiplied the negative times the negative makes it positive.
You're taking the top problem.
Yeah, I took the top one, but if you wanted, you could do the bottom one.
Okay, and then just fill in what you.
Fill in what I got for y, yeah. So the 105s on the left go away, and that's a negative 110 there. Then divide by 2, and we get negative 55. So we got some big numbers, but that's okay. So my ordered pair is negative 55, negative 21. If I plug negative 55 and negative 21 into both, I'll get a true statement. It'll work. That's elimination. So again, you're looking for the same number in front. Well, you always have this situation where there'll be a number in front that's the same for both. No. Okay? So what do you have to do then? To make them the same. You guys remember? You got to multiply one of them or both of them to get either the x's the same or the y. Let's say we wanted, let's just say that was a 3x there. And we wanted to get the y's the same. I'd multiply the top by 8 and the bottom by 5, everything. Then I'd get 40s in front of the y. And then I would go ahead and do that. Okay? Let's say this top one just was nothing in front of that x. I probably would multiply the top by 2, everything, to make it 2x and negative 10y and negative 10, and then put them together. Okay? So sometimes you got to multiply both equations by a number to get either the same number in front of the x's or the y's, or just one of the equations you got to multiply.
Does it have to be like the least common one, or like can it be anyone?
It could be anything.
Okay.
Yeah, just so they're the same. Okay? So let's look at here. Here's that type of problem. This top example 2. Let me get example 3 down here a little bit more. Just a sec. All right. So this is your choice. Okay, so let's look at, how about Mary? Do you want to get the x's the same or the y's the same? Your choice. Okay, she shows the x's. So what do I make both of them? 6, that's what I just take the number in the bottom, multiplied by the top, the number top by the bottom. So when I multiply the top equation by 2, if it'll let me. Oops, that's the wrong one. And then the bottom equation, I'm going to multiply by 3. So I get 6x for both. Does that make sense? All right, so you guys go ahead and finish up, then we'll go over it. I'm worried about the past. Yeah, we're about the future, right? Who?
St. V, huh?
You plug in the original one, right?
Yeah, that's what I do. Once you find one of them?
Yeah.
Get to work. Yes.
It's so good. All the There's like two chords that I'm singing on, and then he'll literally write like a whole, like, first verse for my song, like, it's insane. And then we, like, you're not gonna start working with something or something. And he was like, I'm gonna do this project, we have people in the Oh my god, this was like actually really. What does that mean? Really good. Like I just like to go.
I don't know what it is. You do. Nothing.
Kind of stuck here. Am I gonna get a
Yeah, you get a decimal or a fraction. It's not gonna be a whole number. It doesn't always come out the whole numbers, that's okay.
I got a whole number.
You did?
Yeah.
Are you learning now? Yeah.
Yeah, for maybe 2 weeks.
I hope so.
How does each get eliminated?
She doesn't know why did she?
Okay.
Right.
That's not screaming you. Just to talk.
Mike.
I know, I'm looking at
Let's get it. Well,
She also texted
How did
me
you
mom.
did fraction? That's right, it's negative 8 minus.
She wanted me to highlight Sarah.
And then you got 20 minus negative 26.
So what happened here? Yeah, you got numbers, right? You got fractions, didn't you? That's okay. You're not wrong, okay? So this top one becomes 6x minus 8y equals 20. Remember to distribute all the way through, and you get 6x. Come on, let's focus, please. Now, in order for these to be eliminated, those 6 x's, do I add them together or subtract them? Subtract them. This time when the signs are the same, both are positive 6's, you subtract. We're looking at the signs of the 6's. I'm not looking at the signs of the y's. The 6's, the x's. All right, so we're going to subtract. So those cancel. So remember, what is negative 8 minus 15? Negative 23. What's 20 minus a negative 3? 23. So it comes out nice for the y's, doesn't it? All right, remember, we're subtracting everything. So negative 8 minus 15 is negative 23, and then 20 minus a negative 3 is a positive, so that's 23. So the y's came out nice. Now the x might be a fraction. How do I find x? Plug into either one, right? So this time I'm going to do this one, the second one. It doesn't matter though. So I go 2x plus 5 times negative 1 equals negative 1, which is 2x minus 5, right? Add 5. We get 2x equals 4. 5 by 2, x is 2. So we didn't get any fractions, did we? Okay. Questions on that? Especially. You can do any of the 4. I always do one of the original ones. It doesn't matter. It still should come out to be the same thing. All right, let's try one more. You guys have done a good job today. You guys do this, all of this by yourself. See how you do.
I thought you didn't like. Oh, I don't like them. No.
What do you add them or subtract one? You have to add or subtract.
You get 305. I always want to find a true or false.
No.
Correct?
Yeah. What's 616? 6 minus.
Oh, yeah, that's here. Oh, wow.
So is that true or false? So now
It's literally subtracted from this.
What did I say?
I'm gonna touch zero.
Would add or subtract? Good.
All right, so what happened here? What'd you have to do to the top? Multiply by 3 to get the x's the same, or to get the y's the same, you have to multiply by 3, right? It's your choice, again, x's or y's, okay? So, when we get, and I'll just put it underneath here. Are the signs for the 3's the same or different? Same. What do we do?
Subtract.
Right. Same starts with an S. Subtract starts with an S, right? So when they're the same, we subtract. And what happens? True or false? True. So is that a no solution or infinite solution? That's an infinite solution. So anything we pick for x and then figure out y is going to work. Okay, that could happen too. So sometimes you get no solution in substitution or elimination, and sometimes you get an infinite number solution. Yes. Yeah, you don't have to do anything to the second one, but it's not wrong if you multiply by 1. Yes. You could, and always add. Yeah. Yeah, that's fine. Hey, listen up. Haley had a good point. Some teachers will teach you to always make the two that you make the same opposite. So if you wanted to multiply the top by -3, then you got opposites always, and then when they're opposites, you always do what? You always add. If you want to do that, that's okay. All right. Thanks for working today. Good job.